Good morning, everyone. I'm Pranali, your host for today. I welcome each and everyone for today's Sadgun Sang Meet. This is our 280th virtual webinar. Topic for today is Inspection of Compressors API 618.619.672, which shall be taken by Mr. Surendra Singh. Agenda for the Sadgun Summit particulars virtual inauguration by Dr. Sundar Kataria, invoking the blessing of deity chanting of Gayatri Mantra, introduction of speaker, presentation by Mr. Surendra C, question and answer session, closing session. Dr. Sundar Kataria, Chairman and Managing Director of ICS Group Companies, Sadhguru Sangh, conceived and led by Dr. Sundar Kataria, driven with a mission to elevate the quality, safety, and environmental awareness levels of industry. Sadhguru Sangh is a series of educative, informative events aiming to illuminate professionals on possible solutions to current issues of industry and economy. His designation and organization: Chairman and Managing Director of International Certification Services Private Limited, Academic Qualification Mechanical Engineering, Honorary Doctorate Business Management, Experience Nuclear Lab. He started his career in building India's first nuclear power plant at Rawatbhatta, Kota, Rajasthan. Oil and Gas EIL. He contributed in developing India's first oil and gas field at Bombay High since its inception. DNV. He was a head of industry and offshore development with DNV for 2 decades. ICS. He is a founder of a first Indian conformity assessment and inspection body known as International Certification Services Private Limited, which is a provider of a total quality solution under single umbrella with a wide spectrum of services. Achievements and Award. Lifetime Achievement Award of NACE Kokon. Received several national and international awards. Now I request Dr. Sundar Kataria sir to virtually inaugurate today's session.
शुभं कुरु त्वं कल्याणम् आरोग्यं धनसम्पदः शत्रुबुद्धिविनाशाय दीपज्योतिर्नमोऽस्तु ते दीपज्योतिर्नमोऽस्तु ते शुभं कुरु त्वं कल्याणम् आरोग्यं धनसम्पदः शुभं कुरु त्वं कल्याणम् आरोग्यं धनसम्पदः.
Please join us for the recitation of the Gayatri Mantra. Introduction of the keynote speaker. Mr. Surendra Singh, Designation and Organization Deputy General Manager, Certification in International Certification Services Private Limited, Academic Qualification, Diploma in Mechanical Engineering, Lead Auditor, QMS, EMS, OHSMS, and Level 2 in RT, UT, MT, PT. Achievements and Awards: Best Reviewer in 2025 from ICS and Best Auditor in 2019 from ICS. Experience: total 31 years of experience, 13 years in a fastener line, compressor manufacturing plant, 18 years with ICS in inspection and auditing core. Welcome, Mr. Surendra sir. Over to you, sir.
Okay, now I'm audible clearly to each and everyone.
Yes, yes.
Okay, okay. So I'm sharing my screen. Now my screen is visible to everyone. My screen is visible to everyone.
Yes, sir.
Okay, so first of all, good morning to all the attendee. I'm presenting this topic as inspection of compressor, and my topic is covering first this definition of compressor, second type of compressor, third use of compressor, then fourth difference between pump and compressor, and finally inspection as per the standard American Petroleum Institute 618, 619, and 672 standard. So coming to the definition part, a compressor is known as mechanical device. Compressor either increase the pressure energy of a gas by reducing its volume or increase the pressure energy by increasing the velocity energy by pressure. So by this definition, you can see that the basic principle of compressor is to reduce the volume to and the finally the increase the pressure. This topic is so crucial since this device give uh, in day-to-day life. This device give impact. So many huge we see in our day-to-day life. Even we have the one of natural compressor in our body, which is God gifted. This is lungs. Lungs also work on the compression principle. When these lungs breathe the oxygen from the atmosphere, lungs expand, volume increase. Vice versa, when these lungs uh, emit the CO2 from the body, lungs shrink, pressure develop, and then CO2 out from our body. So you can see that the very vast huge are there in our day-to-day life. Uh, from the man-made compressor, we can see numerous examples in our day-to-day life. When we need the ice creams or the chilled water bottles, we need a fridge, and fridge have a compressor. Similarly, AC, air conditioner have the compressor, the water cooler have the compressor. So the numerous examples we can see in our day-to-day life, which even we get the petrol from the petrol pumps. So this petrol leads to the petrol pump through the compressor, intermediate compressor stations. Uh, these are the types of compressor. Basically, on the basis of the principle, there are two types of compressor are available. One is the reciprocating type. This reciprocating type compressor work on the push and pull principle, and the second one is the rotary compressor, which work on the rotating principle. So these two are the primarily classifications. Further, rotary compressor can be categorized based on their construction part into five category. One is low type compressor, second one is the screw type compressor, third one is the waste type compressor, fourth one is the centrifugal compressor, and the last one is the axial compressor. You can see in this picture, I taken and shown the very general picture in first screen. This first picture, this is a reciprocating compressors, and simply we can say this compress the air and deliver to the users. The second one is a bicycle. This we can see in our day-to-day life that this bicycle, it's actually we tell this bicycle pump, but it's a actually bicycle compressor. So this also work on the reciprocating principle. And in the last picture, you can see this cross-sectional view. Actually, this crankshaft once rotate. So this connecting rod push or pull. Then when this come to this side, this suction valve open, then this air come to this cylinder. Vice versa, when this piston move to towards this side, then this suction valve close, this discharge valve open, and pressurized air goes to this side. So this is pictorial view for reciprocating compressor type. The second picture is showing the rotary lobe type compressor. In this picture, the left side is the cross-sectional view and the right side is the principle how this lobe type compressor works. So in this picture, you can see when these are two lobes, right? So when this lobes rotate to this side, so it take the air amount, and with the compression method, this lobe deliver to this outlet. The similar to another lobe which rotate in the opposite direction. So once this is rotating in this side, this will rotate in this side. So again, this will go with the certain amount of the air and pressurize. Then this lobe also will compressor will deliver to this side. So finally, we get the compressed air at this outlet side. The third one is the screw type rotary compressor. Nothing difference between the previous slide. Only the construction is so different. In this compressor, in place of lobe type, this compressor have the screw type. So once this screw rotate in this side, so the second screw rotate in the opposite side, and further this we get the compressed air from this discharge flange. Next one is the winch type compressor. This is totally different compressor from previous to this lobe and screw. Since this wedge type compressor is having only single shaft. Earlier we saw that the both compressor was having two lobes, but in this compressor have only single shaft. So what is the principle of this compressor? You can see that this is the rotor. These are the vanes. Vanes means blades, and these are the slots. So in this slot, these blades move towards this side, and this shaft always in eccentric position, means this shaft is not in center. So you can see in this picture that this is the inlet, and inlet is having this good amount of the air. So once this rotor rotate in the sides, so if volume decrease, once volume is decreased, and this is the final decrement of the volume, then air compress, and finally this air is delivered by this rotor at this point, and finally we get the compressed air at this point. These blades are movable, so whenever this rotor is rotating this side, this blade come to inside, volume reduce, we get the finally pressurized air. This is a centrifugal type. Basically, this type of compressor take the suction air from the circumferential side and deliver to the same circumferential side. And finally, this is the axle type, nothing different. You can see in our day-to-day life that exhaust fan, ceiling fan, pedestal fans working on same principle. This axle type compressor take the uh, air from the suction side to the axial, parallel to the axis, and then deliver to the same plane. So you can see in the same exhaust fan is there. They work on the same principle. Now, use of compressor. Compressor can be used either for the storage. We saw that the air compressor, which we use for the tire inflation, and when the compressor is being used on the real-time basis, we call blower, and we need to store the gas. Then we use a reciprocating compressor. Use of reciprocating compressor in the petroleum industry. This is a one good thing of this reciprocating compressor when we need the high pressure, low discharge or low volume. then we use this reciprocating compressor. So when the high pressure is required and low to medium volume, means the volume is not required in a huge amount, then we required this reciprocating compressor. And this compressor can be used in the upstream, means in the oil well, exploration site, and downstream, means during the refinery and during the process plant. Here you can see the elaboration of the use. So these type of reciprocating compressor we use in the gas lift operation. We use when we need to inject the high pressure gas into oil wells. Gas gathering and transportation upstream, when we use compress raw natural gas from wellheads and transport it through the pipelines. We need this type of compressors. Also, when we need to gas reinjection in oil well, we need same reciprocating compressor. If we need the hydrogen compression in the refinery, we need this reciprocating compressor. So you can see through this slide that the various the use are there for the reciprocating compressor. Gas processing and treatment plant for the purification separation of hydrocarbons and the liquefied function process for the LNG. We need this reciprocating compressor. Boil off gas handling. So whenever this cryogenic vapors in LNG and LPG storage terminals, we need this compressor. Refinery utility service. So during the refinery, when we need some, we need also this reciprocating compressor. Basic key regions for use, as I told earlier, that this reciprocating compressor build a very high pressure. It sometimes it exceed to 3000 bar. So when we need a high pressure, low volume, then we need a reciprocating compressor, and it is a basic parameter where we use this reciprocating compressor. Now, coming to the rotary compressor in the petroleum and petrochemicals industry, when we need the real-time basis air with the low pressure and high discharge. Earlier compressor, this reciprocating compressor was uh, uh, this used when the high pressure, low discharge. But rotary compressor, low pressure high discharge. So when the low pressure high discharge is required, we use this rotary compressor. For the continuous, also this is one good thing in this rotary compressor, that we get the oil free air from the rotary compressor. There is no mixing of any percentage of the oil in this air. So when the oil free air is required, we use also the rotary compressor. Some of the use in the petroleum industry, you can see through this slide that we use this rotary compression VRU, that is vapor recovery units. Gas lift system, when we used to need some oil lifting from the well, we need to fit this gas uh, rotary compressor. Process gas handling, when we used to transport the gas from one point to another point, then we use also this rotary compressor. Flare gas recovery, you know that the refinery have some flare system. So whenever this gas need to send to the flare, we need this rotary compressor. Pneumatic conveying in the cement industry, in the coal industry, when the real-time conveying system is required, so on the conveyor, we need to have this rotary compressor. Sludge pumping, if you will see in ETP area, the sludge pumping need a rotary compressor, 2-3 compressor you will always find in the ETP area. Basic reason for use in petroleum industry to oil free, as I told earlier, that we get the oil free air or the gas from this type of compressor. Robots, they can handle corrosive or hazardous gas safely. And the last one, low maintenance, high reliability, ideal for continuous operations. So these are the use of rotary compressor. Now coming to the centrifugal compressor, when earlier two compressors they used when the low pressure high discharge or high pressure low discharge, but when we need the high pressure high discharge, so we use this type of compressor. So whenever we require the high pressure high discharge, so we fit this type of compressor can be fit into the upstream side, means the oil well side, as well as in the downstream side, means the refining process, as well as to the transportation of the gas through the pipeline. So you can see through this slide that several use are there in the oil industry. Upstream side, gas, when we are going to injecting gas into well reservoirs to increase pressure, then we need this centrifugal compressor. Gas lift, if we are injecting the gas from the production through the casing, then we need same compressor. Gas gathering and transportation, again, if we are going to gather the collecting the gas and we need to transport from one end to another end, then again we need this centrifugal compressor. In midstream, that is in processing and handling, if natural gas processing, so these type of compressor used in treatment plants to compress natural gas for processing, such as desulfurization or hydrogen removal. In LNG plants, essential for compressing natural gas, methane, propane, ethylene, before it is cooled into a liquid state for storage and transport. In downstream, in the refining and petrochemicals, for the hydrocracking and the catalytic reforming, we need this centrifugal compressor. Gas supply for instruments, when uh, we need a gas for the equipment or the instrument, then the oil-free compressor or the gas is required. So we need a centrifugal compressor. Summary of key usage, application and purpose, pipeline transport. For the pipeline transport, boosting pressure to move gas long distance. Gas injection, increasing crude oil production from wells. LNG refrigeration, liquefying gas for transport. Refinery process, hydrogen gas compression and hydrocracking. Air separation, production oxygen, nitrogen, and centrifugal compressor are preferred over reciprocating compressor when high continuous flow are required. So as I told, this type of compressor, when we need a high pressure high discharge, so we give the preference over this reciprocating, since reciprocating compressor give the high pressure but give only the low discharge, but this compressor give the high pressure and the high discharge. Now, what is the difference between compressor and pump? Basically, this is even confusing word in the industry. So, pump basically transport the liquid from one place to another place, increasing pressure, whereas a compressor reduce the volume of gas to increase their pressure and density. Pump are used for the liquid transfer, water, oil, etc., while compressors are used to store or transport gases. I shared before to this presentation that our lungs work as a compressor, but one body organ also act as a pump. That is heart. Our heart pump the blood and send to uh, across the body. So we say that our heart is pumping the blood. So you can see that our heart act as a pump and lungs act as a compressor. You can see in elaboration mode that the difference between pump and the compressor. Pump, as I told, that pump handled liquids or solids, compressor handled the gas and the vapors. Pump handles incompressible fluids. Volume does not change significantly, but compressor change the volume so significantly. Working principle: pump increase the fluid kinetic energy just to increase the speed of the fluid, but pressure or pressure to create the flow, but compressor reduce the volume, which is the basic principle of the compressor to increase the density and the pressure. Pump generally do not change fluid density, but compression increase the gas density and often utilize store tanks. Pump are used for the water supply, irrigation, and the hydraulic system. Compressor are used in refrigeration, pneumatic tools, and the air conditioning. Pump are generally more efficient, while compressor require more power since uh, the compressor generates the heat due to the energy required for the compression. And in some scenarios, such as bicycle pump, the common name can be misleading, as I told that actually, in real sense, this is a bicycle compressor, not a bicycle pump, but we usually say this is a bicycle pump. Now, coming to the specific standard, this API 618, which is purely cover the minimum requirement for heavy duty, this reciprocating compressor. So, from the design and some stage to the final testing is covered by this standard, that is American Petroleum Institute 618. So person who is going to inspect the material the compressor must go through with this API 618. 619 API 619 cover the rotary type compressors and cover from the design part to the final testing part. So each and everything from the design to the final testing part is covered under this standard American Petroleum Institute 619. This API 672 cover the centrifugal compressor from the design stage to the final testing stage, which type of testing are required to check the integrity of the centrifugal compressor. It is clear cut given in the respective standards, this 672. Okay. Now coming to the inspection part, when we are going to inspect uh, compressors, either it is 618, 619, 672, we need first have some basic and primary documents, including the QAP drawings, bill of materials, various approval. So whenever we are going to inspect the compressor, we must have all the basic documents, including the inspection codes, the purchase orders issued from by the end user, which may be stated the technical specification. So these are the basic reference documents which we must have before to going to inspect the compressor. When we reach at the site, then we must review the documents of the raw material, including the mill TC with the physical traceability. If the mill TC is there, what is the heat number on the mill TC is reflected, what is the actual on the piece, we have to correlate. And the other materials reports, so many materials are components are fitted in the compressor, so we need to check their test reports, their material test certificates with the physical traceability. One special requirement is given in API 618 as well as in the 619 as well as in the 672, that whenever we are going to check the pressure containing part, it must be unpainted. So this is a special requirement given in API 618. This is logic behind this requirement is that the supplier or the vendor can hide some defects below the painting. So if the compressor or the component is having some defect, so if the surface will be painted, definitely I can miss this defect. So this is a clear cut requirement in the API that the unpainted pressure containing part the inspector will see. Inspectors or the inspection engineer will not test the pressure containing part in the painting condition. Again, visual inspection. So after that certificate and the TC reviewer, then inspector will see the visual inspection, visual defects for the casting for crack, porosity, shrinkage. Then he will carry out the NDD as per the approved QP, that is radiography is, if applicable, UT is applicable, MPT is applicable, and LPT is applicable. All four NDT method are reflected in API 618. So it is up to the user that which kind of the NDT method he have reflected in their QAP. So inspection engineer must follow the respective QAP. Then coming to the dimensional check, the various components are fitted in the compressor. So before to assembly, if the QAP need that the stage inspection is required, so you need to carry out the dimensional checks, include the shaft diameter, inspections, inlet and outlet fans, pulley size, keyway size, any other critical dimensions which is reflected in the QAP. So you need to take care while you are doing the dimensional inspection that carefully dimension has to be inspected. I am just sharing a one example. If you will not carefully inspect the shaft diameter where the bearing will come, so if the diameter shall be plus or minus from the tool length, and if you will fit the bearing, definitely either bearing will be damaged, either shaft will be damaged. So carefully the dimension has to be checked. For the castings defects, we are doing the visual inspection. The casting defects may be there, so you need to check during the visual inspection or during the NDT. So cracks may be there, surface imperfection may be there, uh, then sand inclusion may be there, porosity may be there, shrinkage may be there. So then the blowholes may be there. We can see the type of the defects which can occur in the castings in the next slides. These are the pictorial view of the casting defects. You can see this is the mismatching. So this upper part is mismatched from the lower part. Pinholes, you can see that the gas interrupt is there. That's why this pinhole occurs. Old sets, hot tears, some slag inclusion. It may be on the surface or may be captured through the NDT method. Then the misrun, मेटल पेनिट्रेशन, श्रिंकेज और कैविटी, ठंडा होने के बाद जब वो वॉल्यूम कम हो जाता है दैट श्रिंकेज, देन desired dimensions, swell, drops, excess material, then the hard spots, open holes which are open to the surface, blow holes which are inside the castings. So these are various type of casting defects. Some of the casting defects you can capture or you can detect through the naked eye, but some of the defects you may not be able to detect from the naked eye. So that time we need the NDT method. Forging defects which occur on the forging parts, since this compressor having the casting as well as the forging shaft come from the forging side. So forging defects we must aware. So which type of the forging defects can come in on forging material. You can see that old set may be there, die sheet defect may be there, cracks may be there, or the scaling also may be there. So we will see in the next slide in the pictorial form. These are the forging defects which can occur. So you can see this is a unfilled section. This is a unfilled. Unfilled means the material shortage is there. That's why the unclean portion is there. So this unfilled section may be there. Scaling of the pit may be there as a forging defect. Old set may be there. Die mismatching again. This upper part is just mismatch from the lower part is also one forging defect. Flags may be there. Grain growth, this defect may be there, and we can capture through the microscope. Surface cracking may be there, so you can see that the crack are there. Then the residual stress are there. So these are the forging defects may occur in the forging. But first must aware that which kind of the forging defects come in the forging parts. Okay, now after the visual inspection, now we have to check the hardness of part, maybe on parent metal part, then the welding. If welding is there, then we have to check the hardness on the weld area. Then on the heat affected zone, so hardness, any other testing which are required in the QP, you have to also witness. Now coming to the testing part, the hydraulic and the gas leakage of the pressure containing part for as per API 618 to be carried out, that is cylinder bore and gas passage at 1.5 times of maximum allowable working pressure. So this is a one reference criteria given in the API 618, that the hydraulic pressure must be 1.5 times of the maximum allowable working pressure. So if my maximum allowable working pressure suppose is 40 kg per centimeter square, then my hydraulic pressure shall be 1.5 times of 40, that is 60 kg per centimeter square. But in no case it not less than 1.5 kg per centimeter square. This is a condition given additionally while if my compressor is working on very low pressure, means zero point 0.5. So as per this condition, the testing pressure must be 1.5 into zero point 0.5. So maybe testing pressure will be 0.75. But for that case, the condition is given that if the pressure is so low, but at least the hydraulic testing shall be at 1.5 kg per centimeter square. There is a one condition which I have not reflected here, that pressure gauge selection is also one crucial requirement. So whenever we are selecting the pressure gauge, the range shall be of 1.5 to 4 times of the testing pressure. So if my testing pressure is 60 kg, my gauge range shall be 1.5 times 2 of this testing pressure. 60 kg means the testing gauge it will be of 90 kg to 240 kg. So my gauge selection is also one crucial requirement while I am selecting the gauge. Again, after the hydraulic test, there is a gas leakage test is also required in the API 618. So gas leakage, nothing, just a pneumatic test, but the media is given as helium, air or nitrogen based on the working, the what is the fluid will be used after during the service. So if the petroleum product is there, then we have to use the helium as a media for the gas leakage. If the compressor is using in service for the air or other non-hazardous gas, then the air or nitrogen can be used as a gas media for the testing. The time is also given in this code at the minimum 30 minutes to be this pressure to be hold for this gas leakage. Now these are the performance tests given in API 618, that come under the running test. The 4-hour unloaded run test has to be there. You have to witness this 4-hour unloaded run test. Hydraulic pressure testing, which I told earlier, but again we will see in the next slides. Helium gas leak testing, you have to carry it out. Load run test, bar over test. Bar over test is a space customized test for only for the reciprocating type. Then trip speed test also had to be witnessed. So it is not a very critical test. We saw in this. We will see the trip speed during the working, that the compressor must not be tripped below the 110% of the rated speed. So we'll see in the next upcoming slide. Other tests may be specified by the users and also written in the API 618 as noise had to be checked. temperature of the various components, including the lube oil, including the bearing components, had to be checked. RPM, that is revolution per minute, had to be checked. Power consumption had to be checked. Vibration had to be monitored and had to be checked. Then the function of pressure relief valve had to be checked, that if the pressure over pressurization is there, means then this pressure relief valve is functioning or not functioning. Now coming to this hydraulic pressure testing, it's not having some rocket science. Just a simple this manual this uh, pressurized equipment is there. Nowadays, electrical motor is also with system is coming in the industry. So it is a old equipment, but by this equipment we charge the line at a desired pressure for the testing. Here, one requirement generally we confuse in the bar G and bar A. Actually, absolute pressure, gauge pressure, and the atmospheric pressure. There is a three terminology in the pressure. Sorry. So, absolute pressure is equal to gauge pressure plus atmospheric pressure. So whenever QAP is stating this bar G, so you will understand that this is a bar G, bar gauge pressure. So we have to understand between the difference of this bar G and bar A. So when we see bar A means the atmospheric pressure is also added in the gauge pressure that come to this absolute pressure. In this picture, you can see that this reciprocating type compressor is under testing of the hydraulic testing. This gauge is mounted and then pressurization is there. So this is a typical picture is there, and holding time maybe from 13 to 4 hours depending upon the customer as well as API requirement. API 618 state that the pressure holding time shall be 30 minutes, but customer can give some their own requirement, which may be some stringent requirement. So you see first QP, that what is the time written on in the QP for the holding pressure. This is a helium leak testing, nothing special. It's a actually pneumatic testing method. But why we use the helium? Actually, helium is a so lighter gas with comparison to air, with comparison to nitrogen. तो जब हम लोग इसमें when we fill this uh, air, so air may have some chance, it may not come from leakage point, but helium, since it is a so lighter gas, so we use this helium leak testing, helium media to use during this pneumatic. So simply we fill the helium in to the compressor and we pack with helium, then we submerge this compressor into the water. So if any leakage will be there, definitely the bubbles come out from the blowers to compressors and will travel to the this water surface. So we can detect that any leakage are there. So only the purpose of helium is to since this is lighter gas, so if any possibility is there which cannot detect in the air from the air or from the nitrogen, so definitely this leakage will come out from the helium. So that's why we use this helium gas in this pneumatic testing. Now, coming to this 4 hours unloaded run test, which need to perform in line with 618. During this 4 hour unloaded run test, we need to monitor this lube oil pressure, lube oil temperature, bearing temperature, lube oil viscosity, power consumption, rotor speed, vibration, and that all the parameters will be within the limit defined either in the procedure of the client procedure or in the QP. There are criteria given in the API that the power consumption shall not be more than 3% of the rated power value indicated in the data sheet. Means if I am declaring that my compile consume the 100 kilowatt, so the range my compressor shall not take the maximum, cannot go beyond 103 because 3% is the more than tolerance is given. So my compressor shall consume only maximum 103 kilowatt. So this is a one requirement and the tolerance given in the 618. Another requirement is given in 618 is that the trip speed of the compressor shall not be less than 1/10 of the rotor rated speed. So if I am declaring that my compressor rated speed is 1000 RPM, so my compressor shall not be tripped below the 1110 RPM. So this is the requirement. So if I am declaring that my rated speed is 1000 RPM, so this is a requirement. इससे पहले the compressor shall not be stopped, not be tripped. Else, the test result will be in the failure side, and you will give some remarks that the test did not succeed. No leakage must be seen. Another requirement defined in 618 that no leakage must be seen during the test, and the pressure drop of filter element shall not exceed specified value. So we have to check that the pressure drop of filter element is not there. No abnormal sound shall be confirmed during the running test. So any abnormal sound, if you are feeling, if you are feeling that something you are hearing, so you just note down that the crankcase vibration is measured. Again, this is vibration measured. So crankcase vibration is measured in the real time basis in x and y axis, means in the horizontal direction, the vertical direction, and the cylinder vibration is measured in three direction, means in the x and y and z. And the criteria of vibration is given in API 618. So the vibration shall not be go beyond the criteria. This is a criteria of the vibration which I told earlier is given in the 618 that the if the frequency it's 10 hertz of the vibration, the magnitude of vibration shall not be more than 4.5 mm per second. So first you ask to the vendor to calculate the frequency, what is the frequency is coming of the vibration. Then if the frequency is going to higher than 10 hertz, then the magnitude is not more than to 4.5
So,
mm per second,
so your
which is
screen is not visible.
okay, okay, just a minute, right. Now my screen is visible.
Yes.
My okay.
Yes.
So this is the criteria which is given in API 618 for the vibration, that if first the vendor will check the identify the magnitude of the frequency, then when he will come to know that what is the frequency, and then if the frequency is going to higher than 10 hertz, then the magnitude of the vibration shall not be more than 4.5 meter per second. How we can check the vibration? I will brief in the next upcoming slides. The document I reflected, so you can check through the instruments. There is one requirement also for this reciprocating, that aerodynamic performance testing to be performed in line with ISO 1217 requirement with cylinder valves installed in the closed loop system. So basically, it's a the graphical test. So first vendor have to plot a graph or the curve, then as per the ISO 1217 requirement, and then you need to compare this plotted graph with the required value or the the reference graph. So if the plotted graph is going to beyond the limit, then you can say ki my test result is not in line. So then you can ask to a vendor to correct the test. Now this is a customized bar-over test which is only applicable to the reciprocating type compressor. So this bar-over test, nothing a special test actually. We need to check the clearance between the cylinder and piston at extreme end to check the operation efficacy that the my piston is in the exact conditions. So we need to check through the manually. First, what we do, we just rotate the crank by manually at the extreme point. When piston go to the extreme side, we inside a filler gauge or inside some predetermined thickness, any filler material or the lead material. So we come to know that what is the gap is there between the cylinder to the piston. So this give the clearance to us to check the health of the piston. The second one is the run out. So run out, how we check? We check the in next slide we will see in the picture also. But how we can check? We just put a dial indicator on the piston shaft. So once piston move push and pull side, so this diameter, this indicator give a reading to us that what is the run out on the vertical side and the horizontal side. We need to check in both side, horizontal and vertical. So once piston move push and pull side, so this okay. In this slide, you can see that this is a dial indicator. This is the piston shaft. So when this piston shaft move towards this side to this side, so this
Again, your screen is not visible.
just a minute, just a minute.
Yes.
Now screen is visible.
Yes.
Okay, so bar over test we can see through this pictorial form. This is a dial indicator. This is a piston rod. So this piston rod move towards this side to this
So it's
side.
not visible.
Inside this compressor there is a piston. So we need to check. No, again, not visible.
No, sir.
Visible.
No, sir.
Okay. Now it's visible.
Yes.
Okay. So we need to check the this piston run out, piston shaft run out. So it's a simple test, but it give a reflection that what's the health of our compressor. So when this piston rod moved from this side to this side, and this dial indicator we touch on this shaft. So this dial indicator give a run out of this piston rod, and run out reference for the tolerance is given in APS 618 that in no case it shall be more than the 0.64. So if this runout is coming beyond the limit, 0.7 is coming, 0.8 is coming, means our piston rod having much runout and need to repair, means the our compressor is asking for overhauling. So This is a vertical runout. Now, if we are going to check the horizontal, so this dial had to be placed here. So that we will check this horizontal place, horizontal runout. This is a vertical runout. It's a horizontal. So it's a simple test. So it's a bar over test which is applicable as per API 618 for the reciprocating compression. Now, after the performance test, we need to check these safety interlocks, which are the part, maybe the part of the compressor, maybe the part of the canopy or the enclosures. But these are also the essential devices for the safety. So first one is the GD. GD means gas detector. FD means flame detector. SV or the PRV means safety valve or the pressure relief valve. So how we can check? So contractor or the supplier or the vendor who is manufacturer will arrange first will he have a torch of methane or the LPG or the natural gas. So he flow the gas through the torch to this sensor. So once the sensor sense the nearby gas presence, so automatically the sensor give the signal to the control panel, and automatically the compressor must be stopped, means the compressor will go to the shutdown. So we check the safety interlocks through the torch. Again, flame detector, we show a neck flame to the sensor, and if the sensor is working, the switch this compressor will stop immediately. So we check these safety interlocks through the practical inspection. For the safety valve or the PRV valve, we need to give the over pressurization. We give the excess pressure 125% or the 130%, which is the setting defined in the QAP. So whenever this over pressurization will reach up to the 125% of the maximum allowable working pressure, this device automatically open and the pressure released from that area. So we need to check during the inspection in line with the QAP requirement. Other safety interlocks have to be checked as per the QAP. If the high temperature of lube is going beyond the limit, then the compressor must be stopped. Low flow or high flow, if the flow is uh, below the limit or out of the limit, above the limit, then again the compressor must be stopped. Then other safety interlocks which is defined by users must be checked during the uh, uh, inspection. Okay, this is another standard of vibration. This ISO 1016, apart from this API 618. Basically, this ISO 10816 cover the vibration in service of the compressor. So this is a table which is given in ISO 1016. So here you can see, first I have to select that my compressor is falling in class 1 category, class 2 category, class 3 category or class 4 category. It is given by the users. So if my compressor is falling in class 1, that is in small machines, so I have the criteria, that is 0.28 meter mm per second, 0.45 mm per second, and 0.7171. So these three are my safe zone. So if my compressor vibration is coming up to 0.7, 0.71, 0.69, 0.48, 0.5, means not going beyond this limit. So I can say my compressor vibration in this zone, and my compressor is very safe. I don't need to overhaul my compressor. This is why crucial, since the vibration give the overall picture of that the compressor is asking for any overhauling or not. So for the class second, this is the safe zone up to the 1.12 mm per second. Left side you can see this is inch per second. So this is a conversion. It's not a, the, if you are measuring in the inch per second, that 0.01. So this is the basically the acceptance rate to for class 1 for my compressor. For the class 4, my acceptance range is up to the 2.8. Okay. Now, if my compressor vibration is coming to 11.2 for the class 1, so means I am in red zone. If I am in the red zone, immediately I need to overhaul my compressor to take shutdowns and go for the reholing, overhauling. Okay. For the API 619, again, as I told earlier, this is applicable to the rotary blower, but same requirement are commonly applicable to 619, means you must have the QAP drawings beyond various approvals you must have before going to inspect the items. Miltc, you have to review the Miltc with their traceability, physical traceability, other metal records you have to verify. Again, this is requirement given in the API 619 that the pressure containing part must be unpainted. So that is a common requirement already given in 618, 619 as well as in 612. So generally, few vendors what they do now, they offer the compressor in painting stage after the painting stage. So it is not permitted through the API 618, 619 and 672. Again, visual inspection, you have to check the defects for on castings for crack, porosity, shrinkage, NDD, radiography, UT, MPT, and LPT. As per QAP, you have to witness. Again, dimensional check of components for the shaft diameter, inlet and outlet sense, pulley, cleavage, etc. You have to check. Same hardness of parts, weld, and you have to check at parent metals, welds, and the heat affected zones, hydraulic and the gas leakage of pressure containing part. You have to check. The same requirement is given that the hydraulic pressure shall be the 1.5 times of the maximum allowable working pressure. So in this standard, that is in API 619, if my working allowable pressure is 60 kg, so my testing pressures will be the 1.5 times, means the testing pressure will be the 90 kg per centimeter square. And again, a condition is given that not less than 1.5. So if my compressor is going to test it very lesser pressure at zero point 0.5, so as per this condition, it has to be tested 1.5 times, means at 0.75. But condition is given that the in no case the testing pressure shall be minimum 1.5 kg. Again, gas leakage test shall be gas with gas helium, and time minimum test 30 minutes for both tests. So time is given, the media is given in API 619. Again, we have to check the assembly for proper fitment, gap, pillions of lobes, backlash of gears, turnout of shaft. We'll see in the next slides, next upcoming. Here, balancing is a one critical requirement for all the three types of compressor, which I have not captured in this 618, but here's in 619 I have covered. So we'll see. Actually, this balance, if the unbalanced material will be there on the rotating part, definitely it will be the cause of the more vibration. So when the unbalanced material is there, means the vibration will be there. So we do the balancing to minimize the vibration, and typically either we add the weight or either we remove the material from the unbalanced side. So we'll see in the next slide how we do the balancing. This is a balancing setup. You can see this is a balancing machine. This is a display panel. This is the coupling, and this is the test piece. This is the rotor. So when we are going to check the unbalanced material, first we need to place this rotor, this rotating part of the compressor on the rollers. These are two side, one side rollers. This is the second side rollers. So we need to place this rotating part here. Then we need to connect this rotating part, our rotating part, to connect with the machine rotating part through the coupling. So once this rotor is connected well with the machine, then we start the machine. Once we start the machine, this rotor rotate with the machine motor. Okay, automatically, since this machine is having the software, so automatically this machine give the unbalanced material within a 1 or 2 minutes. This is a left plane and this is the right plane. So left plane, right plane. So this machine reflect that what is the unbalanced material at left plane at which angle, and same this machine reflect that at right angle what is the unbalanced material and what is the angle of the unbalanced material. So do you, from this display we can get that what is the unbalanced material we have to remove to balance this rotor. So after come to know that what is the unbalanced material, then we need to select the method. Either we can remove the unbalanced material from the rotor through the drilling, or either we can add through the welding or some riveting method. कभी कभी आपने देखा होगा, आई थिंक इन आवर जो कार का हम लोग बैलेंसिंग करवाते हैं गाड़ी का, तो द बैलेंसिंग पीपल जस्ट अफेक्ट से स्ट्रिक, क्योंकि बैलेंसिंग उधर रिम में द ड्रिलिंग इज नॉट पॉसिबल सिंस इफ विल डू द ड्रिलिंग ऑन आवर कार रिम, so definitely the strength will be lesser and will cause of accident. That's why we need to select based on the practicality that the material removal is feasible or material adding is feasible. So that's why we select the appropriate method to balance the uh, rotating part. This is a ISO 1940 Part 1 is the standard for the mechanical vibration balancing quality requirements for rotor in a constant rigid part. So the grade is there, which grade I am selecting, and against the grade there is a criteria given. If I am selecting the grade 1, so there is a unbalanced material is permitted as 2.6 gram. So we have to categorize our rotating part in a grade, then we can choose that what unbalanced material we can leave as it is in our rotating part. So this is a balancing I covered here. Again, API 619 states that 4-hour unload run test shall be there. Overspeed at test at 110% area, 11% times to be conducted. Again, same test is there. Noise, temperature, RPM, power consumption, vibration, function of pressure relief valve. All are the common tests which we have discussed in API 618. 619 hydraulic pressure test, same requirement are there. So 1.5 times of working allowable working pressure has to be tested. Mechanical test has to be done for the 4 hours, and same the check parameter are there. We have to check the leaks, any abnormal noise, any stable bearing temperature. Again, vibration testing is there, which is defined in API 619. The vibration limit shall be 2.5 meter per second at peak position for main bearing. So how we can check the vibration will come see in the upcoming slides. There I have reflected the instrument picture. This is a criteria given in API 619 that the performance test, if I am declaring that my power consumption is so and so, it shall be within 4%. The 618 stated 3% earlier, but here 619 stated 4%. So first you have go through the requirement, either it is stated in the QOP or in the relevant standard. So if I am declaring that my compressor will consume 100 kilowatt, so my range shall be 100 to 104. Lesser consumption will be accepted, but more consumption will not be accepted from the energy point of view. Mechanical checks, we have to check the this internal clearance of the compressors, then the thrust bearing clearance, timing, gear backlash. So these are the assembly points and we have to check during the assembly. Pulsation analysis is also one requirement under the API 619. So we have to check. The same check parameters are applicable to the IPS 61712. Availability of the QP, drawings, BOM, various approvals, then the NDT methods. Same visual inspection you have to do for the defects, crack, porosity, dimensional checks for components, sharp dia inspection, then inlet and the outlet flange, pulley keyway, etc. Same hardness you have to check at parent metal, weld, heat affected zone, then testing. The same requirement are reflected in EPH 671, 672, sorry, that the testing pressure shall be 1.5 times of the 1.5 times of the maximum allowable pressure, and then the 1.5 the lower side if the low pressure is there. Again, gas leakage shall be same with the helium with 30 minutes holding pressure. Other tests, balancing of rotating part we saw earlier, and then the assembly of compressor. If it is in our scope in the QP, then we have to check the proper fitment, depth, clearance of impellers, turnout of shafts. Same requirement are in this 672 that overspeed is a 10%. You have to check the compressor must not be tripped below the 10%. Same for our unload gun test. Then the test specified by users has noise, temperature, RPM, power consumption, vibration, function of pressure relief valve, etc. These are few criteria that you have to check the full speed load, 4 hours, then the vibration analysis again, then air quality testing, a dew point also in this 671, a dew point check also you have to check. Lubrication system, visually you have to check the functionality of the lubrication system, then the pressure, then the temperature, and you have to measure also through the temperature indicator, through the pressure indicator that my lubrication system is doing during the operation is going in the right direction. Any abnormality is not observed, or the temperature is within the limit, pressure of the lube is the within the limit. Okay, now coming to the testing part, the which parameter we have to monitor, what is the unit, what equipment you have to use, it's written here. So if we are going to check the power consumption, so we need to check the electrical parameters and then the power consumption. So current we need to we need to witness voltage, we need to witness the watt, that is power consumption. Unit is the ampere, volt, and the kilowatt is the unit respectively. If the driver source is from mechanical side, then we need to check the fuel consumption through the fuel flow meter, and then the unit is the liter per hour, which is the fuel consumption unit. The instrument required for the above measurement is clamp meter, multifunction meter, watt meter, and the fuel meter. When we are going to check the fluid property, that is flow delivery, pressure, temperature. So we will check in the unit kg per hour or the SCMH for the flow delivery. If we are going to inspect the pressure, then the unit shall be in the kg per centimeter square or bar g or pound per square inch gauge. So this is a pressure unit. And if we are going to check the temperature, then the temperature unit shall be degree centigrade. And the instrument is required for the above measurement are the flow meter, pressure gauge, pressure transmitter, temperature gauge, temperature transmitter. If we are going to check the vibration, then we need a instrument. The unit is meter per second or micron. So there is a two method to check the vibration. Either we can check in meter per second or micron. API 618, 619, or 672 clear cut state that you have to check the vibration in meter per second, which we discussed in previous slides. For that measurement, we need the instrument as vibration meter. If we are going to check the component temperature, the unit shall be the degree centigrade. Instrument is required to check this component temperature, thermocouple, RTD, thermistor, IR sensor, and other like laser guns. Nowadays, the laser gun is come in the picture in the industry, so you can check the temperature through this laser gun. Function checks of interlocks can check the gas detector, flame detector, hooters, emergency switch, CO2 flooding system. So they are the visual checking. There is no need to, no unit is required, no equipment is required. Only you have to check that the tripping system is there if the any parameter is going beyond the limit. So you just check that the compressor is tripped or not on the required level. If we are going to check the sound pressure, then the unit we have to measure in the decibel. So we always check this sound pressure in decibel, and instrument is required to check this sound pressure is dB meter. Sometimes we say this is noise meter. If we are going to check the revolution per minute, that is RPM, so the unit is the number, simple number is the unit, and instrument is required as tachometer. So tachometer give a reading of RPM of any rotating part. Special requirements in CNG compressor that valid PSO approval shall be there. Physical item traceability will discussed in previous slides. When we are going to check the sorry, actually I was disconnected, so I'm connecting it again, and I'm sharing my presentation. Just a bit. Am I audible? Na? Am I audible?
Yes, sir, you're all good.
Okay. So I was there. I think sound pressure we can check through the dB meter. RPM we can check through the tachometer. In the CNG compressor, we must check that valid PASO is there. Physical item traceability with rates tested with we discussed in previous slides. One more critical requirement we can check that the structural stability if the roof mounted cascade is there. So we have to check that the structural stability certificate is there with the vendor. Now coming to the pictorial, the view of this equipment. In the first picture, you can see that this is a clamp meter which give the ampere, this current measurement, voltage measurement, as well as the resistance measurement. The second is the dB meter, that is noise meter. So whenever we are going to check the any noise, you just keep this sensor at a noise generation source. So this sensor give the reading directly on the display. So in this display, you can see that the level of dB somewhere it is 59.2. This is the vibration meter. So this probe you need to locate at the measuring surface where you are going to take the readings. So this probe automatically give the reflection of the vibration level at this display. So this vibration meter is also having two mode. You select the mode, either you are going to take in the mm per second, or either you are going to take this uh, 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 vibration reading in the micron value. This is the tachometer. So tachometer we use for the measurement of the RPM, and tachometer further categorized into types. One is the contactable, and this is non-contactable. So this was the earlier, the conventional method. So when we are going to check the RPM, we need to put contact this physically this contact surface to the rotating part. So it give a wear tear. So that's why nowadays this instrument is avoided, and this is non-contact based. So how this work? We put a tape or any sensing paper on the rotating pulley. So this sensor through the laser sense this tape rotation. So in 1 minute, how many times this tape is crossing through the sensor, and automatically this calculate and give the reflection of the RPM on this display. This is the PT&TT, that is pressure transmitter and temperature transmitter. This give the signals, take the signals from the pressure gauge from the line, and automatically reflect the pressure readings and the temperature readings in digital form to this display. This is ordinary pressure gauge, manual pressure gauge. You need to read in manual form. In this picture, you can see that the 4 kg pressure is there. Mass flow meter and the SCMH meter used for the flow meter reading. So when we are going to check the flow meter, we need a flow meter. Watt meter to check the consumption of the power. So we check through the watt meter. So watt meter give a direct once the compressor is in operation condition, this pointer give a reflection that what is the wattage this compressor is consuming during the operation. These are some short terminology abbreviation used during the inspection. It may be the part of the QOP. So one who is going to inspect the material compressor, he must aware about the terminology of the short terms. That is D and D, drive and non-drive and PESO, petroleum explosive safety organization, PTTTRD, that is pressure transmitter, temperature transmitter. RTD, that is resistance temperature detector, RPM revolution per minute, DPG, PG differential pressure gauge, and MFM mass flow meter, PID process and instrumentation drawing, GAD general arrangement drawing, GD, MCV, that is net calorific value and the gross calorific value, GD, FD, HD, switch gas detector, flame detector, emergency shutdown switch, BOM, MTC, TC, that is bill of material test certificate, MOC, that is material of construction, RP, W and R, which is the commonly used word in the QP, that is review, perform, witness, and review and hold. Here I am elaborating this H. If H here means this is a hold point. So before clearance of H point, you cannot go ahead for the next stage until unless this H is not completed. So H is means this is a hold position. First you have to clear this position in QOP, then only you will go for the next position. ST hydraulic test, PRV, that is pressure relief valve, BRG, BRA, that is bar gauge and the bar obsolete. These are the commonly applicable standards. 618 is compressor for this reciprocating, 619 is for rotary type lobe, 672 is for centrifugal compressor, ISO 1940 part 1 is rotatory balancing, uh, 10 also 10 816 is for vibration. So first whenever you are going to inspect the material, you go through the requirement are clear cut stated in respective standards. Due to time constraints, I'm not able to reflect all the requirements of the respective standard in this PPT since that time constraint is there. So, request to adhere or go through first to the respective standard, and many things are given in respective standards. So, uh, during the inspection, you need to take care about the PPE adherence like helmets, earplugs, glass masks, and safety shoes. The B point is so critical since in our country, in India, the vendor does not adhere these things. I specifically to the 3 to 4 vendors, I specifically implemented this system that since this is a live testing, when we are going, we are there, we check the performance test, electricity is there. So when we move near to the compressor, electrocution, electrical shock hazard may be there. So before to proceeding any inspection, live inspection of the performance test of the compressor, you need to ensure that the system must be connected through the electrical earthing system. In case of electrical leakage is there, you can save yourself and avoid any loose clothes since the rotating part is there. So loose clothes also give a hazard to you. So thank you and try to best to cover since I was in fever last days. I was in Chandigarh, but thank you covered things. Over to
Now I request all delegates to unmute yourselves and ask questions if you have. You may also type your questions in the chat box.
any question from
So there is a question in the chat box. Uh, what are typical issues observed during performance and capacity test acceptance? So you are unmute, sir.
okay. Yes. What are the issue, typical issue observed during performance and capacity test acceptance? Actually, there are several issues, either from inspector side, either from the this supplier side. So supplier first may have the faulty equipments, right? So he's having the faulty equipments. The readings will not be in line with the actual things. So first we have to ensure that the equipments must be in a fit condition. The accuracy calibration shall be there. Fitness means the uh, precision shall be there. If suppose if we are going to check a pressure, test with us the pressure, and pressure is 60 kg per centimeter square, but range is 2 kg, means the least count is 2 kg. So it may be chance and that the since the list count is so not good, so it may be chance that the you will not get the good reading. One thing. Second thing, uh, intentionally or unintentionally, suppose uh, if we are going to measure a vibration, so vibration need a particular location. Okay, when the rotating device founded is in foundations with the proper clamping with the bolt. So if you will check the vibration at that level, you will get the minimal vibration. But when you will go to upper side, since the distance is so much, so the vibration value shall be there. So the allocation of the location of the measurement is also critical in the vibration measurement. This is one thing. So this type of issue may be there. So as an inspector of the surveyor, we must know where we can get the good value of the or appropriate value of the measurement, so that the exact value we will have.
So there is one more question. How should third-party inspectors handle
Handle license and
deviation and
cons-
concession request?
Actually, third party inspector is not having any right to for any deviation or concession. So if you are getting any deviations, means any parameter which is going beyond the range, so you first just inform to the client, and client, since client is the decision maker, so only client is going to approve or reject. We are just as a the independent agency, just whatever this vendor is having, we just to explore, and we we are the informer, we inform to the client that this parameter is going beyond the limit, so either you please accept, either you please reject. So we are not having the right to approve any deviation or give any deviation. This is the right of the client. The next one is what inspection items are often missed that later affects site commissioning. I could not get you the meanings of this question. Can you elaborate this question? I think I understand that this question is related to the material quantity which is inspected at site and mixed by the manufacturer and they have not sent to the site. So what is the impact will go on the site commission? Definitely, if the question is related to this, the single small part is also crucial in the entire package of the compressor. So if foundation bolt is not sent by, means foundation bolt is a very small, component of this package. So if the manufacturer is not sending this foundation bolt to the site, so how my compressor will be installed at site? So this is if something is maybe will give the impact on the site commissioning. So it is the responsibility of the vendor, which the item which is inspected and cleared by the inspector has to send at site in a with full quantity, with cross checking, and I think this come under the responsibility of the vendor. Okay, what kind of the loopholes in inspection? Loopholes, various loopholes are there in the inspection. If we don't have the, we if we are not reading the, inspection this standards, so how we will, come to know that what is the requirement given in the standards? How, if we are not reading the carefully the QAP, so we miss the requirement and we can clear the things. Second, if we are not competent and vendor is doing the, suppose if I'm not knowing that how I will operate the vernier caliper or the dial indicator, and if vendor is directly measuring the dimensions, he is showing the dial indicator readings, so he can give some, he can give some incorrect reading to me. He can show incorrect reading to me, and then this faulty, reading can be passed by surveyor, and the faulty equipment can be, cleared by the surveyor. So various loops are there, but no doubt we must have first competency, then the documents and the proper readiness before going to the inspection with regards to the documents, QOP, BOM, etc. Yes, any? Okay. Are there any special certification courses to do inspection for compressor? As on date, there is no special certification is there for the inspection of for compressors. Only the self certification is there. So you must have the internal competency. Self certification is a one primary requirement, and I think you take care the self certification means strongly you can say I am fully aware about the requirements, about the things which is briefed in the standards. I am fully aware. I am fully aware about the equipments which are being used, which are maybe used, how it can work, what is the principle of the equipments, how they work, how I can operate. Can you imagine when I go to the inspection, or earlier I went, so I don't allow to the vendor to give the readings through 1 year. I ask every time to just give the document to me. I will check, then only I will be in believing condition that whatever I'm checking it is 100% sure. But when you are asking to the vendor that you please check and you just show me the reading. Definitely, it gives some the negative impact. So there is no special, certification is there. Only the self certification is a one requirement. So you may have seen. Any more questions?
Once again, I request all delegates to unmute yourselves and ask questions. Sir, I see there is no questions anymore, so we are going ahead. Before that, on a behalf of
Yes,
ICS,
yes. Any more question is there?
I don't think so, sir. So we are going ahead.
Okay, okay. Please, ma'am.
Okay. So on behalf of ICS and everyone present at the Sadgun Sangh meet, I would like to sincerely thank you, sir, for delivering such an insightful and informative session on inspection of compressor. Your deep knowledge and practical insights and clear explanation of complex standard made the topic highly engaging and valuable for all of us. We truly appreciate the time and effort you invested in sharing your knowledge and expertise with us. Thank you once again, sir, for wonderful session. We look forward to learning more from you in the future also. Thanks a lot.
Thank you.
Yeah, so we are going ahead. So ICS is placed to provide you all its research and development, integrated management system, QMS, EMS, OHSMS, excellence in education management, ISO made easy in Gujarati, Marathi, Telugu, Hindi, our recent publications, Urja, thermal, oil and gas, nuclear, and second one, jung tak, fight with rust, corrosion causes and its mitigation. For reading any of the above books, please contact Ms. Sushma Kindalkar. Feedback form. Please register on www.sadgunsam.org and go in your login and give feedback. Before closing, I would also like to thank all our participants for their valuable time and active participation. We hope you found the session informative and useful. Have a nice day.